A particle of mass m moves under the influence of the potential v of x is equal to a over x square minus b over x, where a b is greater than 0 means a and b are positive here. The frequency of small oscillations around the equilibrium point is, here you have given 5 options and you have to choose the correct option after solving this problem. This question may be asked in a different way, and that is, you may be asked to find out the frequency of small oscillations about the minima of the potential is. Okay, so whatever the question is, either you have asked to find out the frequency of small oscillations around the equilibrium point, or you have asked to find out the frequency of small oscillations about the minima of the potential, the method would be the same, and that is which I am going to tell you. And this is the potential which is given here. uh, what we have to do, firstly, we will take the derivative of this potential with respect to x, and in the second step we will put that derivative equals to 0 and determine the value of x. So let's start by taking the derivative of this function with respect to x. After taking derivative with respect to x, we get dv over dx is equal to minus 2a over x cube plus b over x square. Now in the second step, we will substitute this derivative equal to 0 and determine the value of x from here. Now 0 is equal to, from the right hand side, we will take 1 over x square common. So in the inside, there remain b minus 2a over x. Okay, this term vanishes. Now after solving this term, we will get x is equal to 2a over b. We will put this term equals to 0, and by simplification we get x is equal to 2a over b. Now here we will use the concept of conservative force. We know that the conservative force is F is equal to minus del V. Del V. As we know that F is equal to minus kx is equal to minus, we can write del V as dV over dx. Okay. So here the negative sign cancel from both sides. This negative and this negative, they get cancel. Now we will again take a derivative on both sides with respect to x. So when we will again take the derivative of both sides with respect to x, there come k is equal to d square v over d square. This is what we get after taking the derivative of this equation with respect to x. Okay, now as we have solved a dv over dx in this step, now what we will do, we will take the derivative of this equation again with respect to x, and we will get the result d square v over dx square. So let's start the simple mathematical calculation. Okay, so when we take the derivative of this term, we get d square v over dx square is equal to, here we get d square v over dx square equals to 6a over x to the power 4 minus 2a over x cube. This is what we get after taking derivative of this term again with respect to x. So this is equals to k. Here I think I should make a partition so that there would remain no confusion. Okay, so I'm going to draw a line here. No, okay. Now here we get the value of k, and that is 6a over x to the power 4 minus 2a over x cube. Now what we will do, we will just substitute the value of x which we have found here in this expression, okay, to determine the value of k. So substitute the value of x here with me. X is equal to 6a over the value of x is 2a by b, okay, 2a by b whole to the power 4 minus 2a over, again substitute the value of x here, 2a over x whole cube. After simplifying this expression, we get k is equal to b to the power 4 over 8a cube. This is the value of x, sorry, k. This is the value of k. Now, as mentioned in the question, that we have to find out the frequency. So to find out the frequency, we will use the general formula. If omega is equal to square root k over m. Here k is the spring constant and m is the mass. And we have found this k in the last expression, this value. We just have to substitute this value in this formula and we get the result. Omega is equal to square root b to the power 4 over 8 ma cube. This is the value of frequency of small oscillation around the equilibrium point. So our correct option is here option number C. This is our correct option.